Welcome back to another Explainer Focus Learners. Today, we are diving into something that literally sounds like it's straight out of a sci-fi movie. We're talking about a radical shift happening right now in how we interact with machines. We're moving away from our trusty smartphones and heading straight into the era of wearable AI and ambient computing. Seriously, the way we interact with the digital world is about to fundamentally change. We're shifting from a reality where we're constantly looking down at our hands to a world where our computers are just seamlessly woven into our environment. It's a pretty bold question, right? But take a second and actually think about that familiar glass device you rely on every single day. Maybe it's in your pocket, or maybe you're even holding it right now. Is it actually on the verge of total obsolescence? Well, industry analysts are increasingly pointing out that wearable AI is the next major battleground. I mean, we've relied on the smartphone form factor for over 15 years at this point. But if you listen to the rumblings in the tech industry, the reign of that pocket-sized screen might be coming to an end a lot faster than we think. Let's just put these two paradigms head-to-head for a second. On one side, we have the glass slab. It's clunky, it demands your total active attention, you have to physically seek out information by tapping and scrolling, and honestly, it just tethers your hands and your eyes. But on the flip side, we have ambient computing. This is the promise of a system that is invisible, passive, and proactive. Instead of you having to dig for information, the system is continuously observing your environment, your audio, your visuals, even your biometrics, and it proactively gives you helpful insights perfectly overlaid onto the real world. So, here's our roadmap for today. 1. The death of the glass slab. 2. The ambient computing shift. 3. Wearable neural interfaces. 4. Retinal displays in AR. And 5. Hardware and future challenges. Let's jump right in. Section 1. The death of the glass slab. We are all definitely experiencing this collective, active, screen-gazing fatigue. You see, industry commentators have noted that by 2025 and 2026, smartphones essentially hit an innovation plateau. Sure, when you upgrade, you might get a slightly faster processor or a marginally better camera. But the actual day-to-day user experience, it stayed exactly the same. The 2D screen has quite literally become a bottleneck. Think about it. Modern generative AI is conversational. It's always on. If you ask your AI to pull up some data, doing that on a smartphone means you have to look away, find the right app, and totally break your connection with the real world around you. Tapping and scrolling just cannot keep up with the speed of human thought anymore. Section 2. The ambient computing shift. Let's move from that screen fatigue to something absolutely fascinating. The ambient paradigm we saw heavily showcased at events like CES 2026. The crucial takeaway here is that major tech players genuinely envision your next personal computer living within the clothes and accessories you wear. We're talking about devices that just sit on your body all day, seeing and hearing the exact same world you do. Heavy hitters like OpenAI, teaming up with legendary designer Johnny Ive, are sending a very clear signal. Future digital assistants are not going to live trapped behind a glass screen. They're going to be woven into your jacket, built into your smart glasses, or pinned to your shirt. The goal is to flip the model entirely. They want to turn that constant stream of environmental data into instant, actionable insights like translations, notes, or reminders delivered exactly when you need them without you ever asking. Section 3. Wearable neural interfaces. Now, you might be wondering, if we don't have a screen to tap or swipe, how on earth do we actually control these futuristic devices? Well, the answer is brain-computer interfaces, or BCIs. Basically, this is technology that bridges the gap between human intention and device action using neural or muscle signals. A really great example of this is the Mudra wristband by Wearable Devices Ltd. It's just a simple band you wear on your arm, and it actually reads the fine nerve and muscle signals in your hands. They even recently announced a partnership with MetaBounce to integrate this tech directly with AR glasses. So in the real world, you might scroll through a menu or click a button just by doing a really subtle wrist curl or a tiny finger twitch. It links your physical intention directly to the device, entirely hands-free. And this tech scales all the way from muscle signals up to your actual brain waves. Companies like Wearable are commercializing non-invasive brain interfaces by hiding tiny EEG sensors inside headsets or even just your everyday earbuds. Their AI actually monitors your brain waves to figure out your cognitive state or what you're focusing on. Back in April 2026, Wearable even announced plans to license its mind-reading BCI API out to other wearable manufacturers. What that means is your headphones or your glasses could soon know exactly which digital element you're focusing on, or even notice when your attention is drifting without you lifting a single finger. 96.4%. That number is just staggering. Academic labs are pushing this technology to absolutely wild new heights. Georgia Tech recently showed off a microscale BCI sensor, which is this tiny 1mm microneedle patch that slips right under your skin. During their study, people wearing this patch on an AR video call could literally think commands just by fixating their vision on targets. The system knew exactly which contact the user wanted to call, and it automatically dialed them with 96.4% accuracy, and the users were totally free to walk around and look at other things while doing it. We are rapidly approaching a world of continuous, thought-driven control. Section 4. Retinal displays and AR. Okay, so we've essentially solved the input problem with neural interfaces. But what about the visual output? Once the physical screens are gone, where are we actually going to look to see all this digital info? Enter Virtual Retinal Display, or VRD. This is a completely screenless technology that scans a tiny, low-power beam of light, usually a laser or an LED, pixel by pixel directly onto your retina. Just imagine putting on a lightweight pair of glasses, but instead of looking at a tiny physical screen inside the lens, you see high-resolution maps, menus, and data visualizations floating perfectly in your real-world environment. Because the image is being formed directly inside your eye on your retina, the brightness and clarity are incredible. No matter what the lighting is like outside, it's completely immune to screen glare. Now, how does this actually work safely? Let's walk through this fascinating three-step process. Step 1. Advanced eye tracking algorithms monitor your eye movements to compensate for what are called microsaccades. Those are the tiny, involuntary little twitches our eyes constantly make. Step 2. Miniaturized microprojectors built right into the frame steer low-power, entirely eye-safe lasers. Step 3. Those images are scanned directly onto your retina. Because of this incredibly fast tracking and projection loop, your digital overlays stay perfectly locked in place, even when you're turning your head or looking around the room. And listen, this isn't just lab science anymore. We are looking at a projected annual growth rate of over 24% for the virtual retinal display market from 2026 onwards. Industry reports are showing that these lightweight retinal projectors are finally moving out of R&D labs and hitting mainstream production lines. This is being driven by falling costs in silicon photonics and massive investments from players making everything from medical vision aids to smart military helmets. VRD is effectively making the traditional screen totally obsolete. No more bad viewing angles, no more restricted fields of view. Section 5. Hardware and future challenges. We need to look at the incredible engine actually powering all this. But to be totally fair, we also need to impartially lay out the roadblocks that could slow this whole thing down. The hardware making this possible is just unbelievable. A massive game changer is Qualcomm's Snapdragon Wear Elite chipset, which is built on a microscopic 3-nanometer process. This thing has a dedicated neural processing unit that can run local generative AI models. We're talking models with roughly 2 billion parameters, right there on the device itself. It gives you days of battery life, and it packs in 5G, Wi-Fi, Bluetooth, and even satellite connectivity. The ultimate goal here is cutting the cord and completely decoupling your wearables from your phone. These specific chips are what allow AI pins and smart glasses to run vision-based AI completely on their own. But let's pump the brakes for a second, because there are some very real-world hurdles to clear. First up, privacy and trust. A wearable device that sees everything you see, hears everything you hear, and literally reads your intent? That raises some profound concerns. The survival of this tech depends completely on rock-solid privacy safeguards and keeping data processing on the device, not up in the cloud. Second is health and safety. Shooting the lasers into eyes means passing strict Class 1 laser regulations, and neural sensors have to be proven safe for long-term skin contact. Third, battery life and comfort. Getting multi-day battery life out of a tiny device that's constantly sensing without it getting uncomfortably hot is a massive engineering headache. And finally, ecosystem compatibility. Thinking your commands requires an entirely new type of operating system and spatial user experience. So while all the building blocks are absolutely falling into place, completely throwing away your smartphone within the next year, that's still highly speculative. Which leaves us with this final, really provocative thought. This silent revolution is already underway. The actual technology to make screens a thing in the past, combining BCI sensors, retinal projection, and those insane 3-nanometer chips, it's already here. But it forces us to make a massive choice. We have to weigh this extreme ambient convenience against some incredibly deep, unprecedented privacy implications. So I'll leave you with this. Are you ready to trade your screen for a brain-reading wearable? It's a question every single one of us is going to have to answer sooner rather than later. Thanks so much for joining me on this explainer. Keep learning, and I will see you in the next one.